channel.
Yeah, definitely. I think there's a lot of economies of scale for for the visitor if they're able to give a few talks and visit a few places. So that
Yeah,
makes sense.
that.
And Yogita, how do you pronounce your name? It's Yogita Shamdasani?
Yeah, that's right.
Yeah, that works. Okay, good.
Yeah.
Good. And Shafat, you're back in KL already?
Yeah, I'm here. I've been here
Okay.
since beginning of this month.
Okay.
Yeah.
Did you have to quarantine still at home or?
At home, yeah, at home, 7 days. So it wasn't a problem.
Okay, you were
Yeah,
just
now
breaking up a
it's
little.
good that. Sorry, yeah, I said I quarantine at home, so it wasn't a problem. But now they're
Okay.
they're relaxing these things, so it's getting easier to get in and quarantining.
Okay, that is good. Yeah.
So where is home for both of you? I guess, I mean, besides KL being current home.
Home. You mean where I grew up or where I'm at home or where I?
Yeah, that's a tough question actually. I should be careful when
Yeah,
I
I mean,
ask
what
this
do you
because
mean by
I
home?
always have,
Home is kind of a.
I guess where you grew up, where you grew up. We can start with that.
I grew up in Germany. I grew up in
Okay.
Germany, and I was there before. I mean, right now I'm traveling. Right now I'm actually in Arizona,
Okay.
but
Okay.
I just was in Germany after leaving Malaysia. After having been there for a year, I go back there, then I go back to Kuala Lumpur.
Okay.
But I don't feel of Germany as home right now. I mean, it's
Where you grew up.
yeah, it's where I grew up, but it's quite
Yeah.
in the distant past, so it's not.
Right.
Hmm. Yeah, so I'm from Pakistan originally, so
Mhm.
I grew up there. I did my undergrad there, so I went to US for the PhD. I graduated in 2020 from the University
Okay.
of Rochester, and then I
Okay.
joined the World Bank Research Group here in Kuala Lumpur. So
Nice.
yeah, I've I've been going back to Pakistan. So for example, I spent the summer there because we could work remotely. So it's been
Right.
nice in that sense.
Yeah. Yeah. Well, Tobias, are you going to be celebrating Thanksgiving?
Yes, I am. I'm actually.
You're missing out on the
I mean, the
pre-Thanksgiving.
party out there already
Yeah.
started. So I'm here. I'm in Arizona. We rented like a place with like friends, and they already started the party. So
Yeah. I can
after the
imagine.
seminar,
I think it's
I'm
the
on
one
leave
holiday that I
officially.
really miss. I really miss Thanksgiving. It's a fun holiday.
Yeah, it's nice. I like it too. Hey, you is on. Hello, you.
Hey, Tobias.
Hey. So it's 9 on the dot. I mean, let's just wait for more people to come on.
Sure.
Another 2 minutes or so. It's usually.
Yeah, we usually actually have our seminar at exactly this time. Sometimes we
Really?
start at 8:30, depending on where the speakers are, and so it's the slow trickle in as people get their morning coffee going.
Okay, so we are probably not going to get too much buy-in from the United States tonight, or this morning.
Unsurprisingly.
Obvious reason, yeah. Okay. But who knows? Okay, Daniel Garrote Sanchez, are you joining from DC?
I am.
I am good. Okay, good evening. Okay. Okay, let's just start and have people join as we move ahead. So welcome everyone to the East Asia and Pacific Chief Economist of a Seminar Series at the World Bank Research Hub in Kuala Lumpur. It's our great pleasure tonight to have, or this morning, I should say, it's our great pleasure this morning to have Yogita Shamdasani with us. Yogita has a PhD from Columbia University in New York. Before that, she has an MA and an MA.Phil in economics, both from Columbia University, and a BA with distinction in mathematics and economics from Cornell. So a strong New York connection there. And she is currently an assistant professor at the National University of Singapore, where she joined in 2020. And before that, she spent 3 years as an assistant professor at the Department of Economics at the University of Pittsburgh. So Yogita is going to talk about a paper I enjoyed very much, which is called Climate Change and Labor Relocation, Evidence from 6 Decades of Indian Censuses. And just a reminder of the house rules. So Yogita will talk for about 35-40 minutes. If you have any questions that you need for clarification, please ask me those questions through the chat. And then I can interrupt Yogita and ask a question. All other questions, please leave them to the end. And also let me know through the chat if you have any questions you would like to ask. So Yogita, without much further ado, welcome.
Great, thank you so much for that very nice introduction. So I have your pictures up. Do you see it on the screen, or is it okay if I keep it up here?
We can see your slides.
You can see my slides. Okay, perfect. Well, thanks so much for having me. It would be a pleasure to meet all of you in person in KL, but it's nice to see that there are people tuning in from the US and other places. So this is joint work with Maggie Liu and Viz Taraz, who are both assistant professors at Smith College. And today I'm going to be talking to you about climate change and labor reallocation. And in this paper, we're going to use 6 decades of data from the Indian census. So to start off, so this is sort of a well-established fact in development or macro development, which is that developing economies are commonly characterized by these large productivity gaps. Okay, so you could think about these gaps in the context of the agricultural and the non-agricultural sectors. You could also think about these gaps between rural and urban areas. Okay, and so the natural point that follows is that reallocation of workers across sectors or across space would be beneficial for development if it allows for a more efficient allocation of human capital. Okay. But at the same time, in order for this sectoral or spatial arbitrage to take place, what we need is both an availability of better paying jobs outside of the rural sector or the agricultural sector, as well as a sufficiently low cost of switching between these sectors or regions. So what we do in this paper is we're going to think about how climate change interacts with labor reallocation, particularly in economies that rely heavily on agriculture. Okay, and so why this focus on economies that rely heavily on agriculture? There's a well-established relationship between temperature and agricultural productivity, right? So higher temperatures have these adverse impacts on agricultural productivity and agricultural income. And so you could imagine in an economy where there's high dependency on agriculture, rising temperatures under climate change could potentially impede the pace at which labor reallocates across sectors and space. So that's the goal in this paper, is to think about this interaction between climate change and labor reallocation. And there's a vast literature that looks at reallocation, sectoral or rural urban reallocation, in response to short-run weather shocks. Okay, so people looking at rainfall shocks or looking at short-run exogenous changes in temperature. But the key here that I want to highlight is that when we think about long-term responses to climate variation, they could differ very fundamentally from these short-run responses. Okay, and why is that? Well, firstly, we want to think about, given that we're looking at it at a much longer span, there could be potential adaptation, or on the flip side, there could be potential intensification of effects. Okay, and so by looking at longer run responses to climate variations, this allows us to better approximate how agents would respond to anthropogenic climate change. So that's the focus of this paper, right? So we acknowledge that there's this large literature that looks at short-run weather shocks, and we're going to add to this by looking at these longer-term responses to climate variations. Okay, and so the two questions that we're going to ask in this paper, the first is, do rising temperatures under climate change affect the pace of reallocation? And we're going to focus on local labor markets, and I'll talk more about what that means. So that's the sort of the big question that we're going to ask, and then the next question we're going to follow up with is, what are the possible mechanisms underlying the effects that we find? And so the way we do this is we assemble a pretty large data set that covers all districts in India for a period of about 6 decades. Okay, so it's 1951 to 2011. And what this allows us to do is it allows us to look at medium and long-term climate variations. Okay, and so just to give you a quick preview of what we find, okay, so the first big result in response to question 1 is that rising temperatures do inhibit structural transformation. Okay, in particular, we see an increase in the share of the labor force that's engaged in agriculture, and a reduction in the share of the labor force that's engaged in non-agriculture. And we find that these effects actually intensify when examined over a longer time frame. Okay, so this goes back to this idea of adaptation versus intensification. And so what we are finding is the latter, is that effects actually intensify over a longer time frame. Then we think about the mechanisms, right? And so this is more suggestive. And so what we find here is that our results seem to be consistent with local demand effects playing a role. Okay, so what do I mean by local demand effects? So if we think about the channel, right? So we're thinking about rising temperatures lead to a reduction in agricultural productivity, a reduction in agricultural incomes. This then drives a reduction in the demand for local goods and services, right, as a result of having lower income. And subsequently, this leads to a reduction in non-agricultural labor demand. Okay, I'm going to talk about other potential mechanisms that you might have in mind, and I'm happy to also chat more about other, you could think of many different mechanisms that could be driving these effects. So what we find is that the evidence seems to be consistent with local demand effects playing an important role. And of course, I'll come back to all of this in a lot more detail. So let me tell you about the context. So we're going to be working in India. Okay, so India, based on the census 2011, is still largely rural. So about 69% of the population is rural. 55% of the labor force is engaged in agriculture. Okay, so a large agricultural economy. And it's been documented that in this setting, structural transformation, so particularly if you think about the movement from agriculture to manufacturing, this process has been slow and stunted. Okay, it's also a setting where migration is pretty low, because we're thinking about both rural-urban migration. Okay, so rural-urban migration is low, as well as cross-district migration being quite low. And so what we're going to do, given these trends in migration, is that we're going to focus on local labor market responses. So we're going to focus on movements of workers within districts, because we're going to think about a district as a local labor market, and we're going to think about how they respond within these local labor markets. So let me tell you a little bit about the data that we're going to use. So we put together a few different data sets. Okay, I'm only going to mention here the key data sets that we use in the main part of the analysis, but we actually have quite a few additional sources that we also describe in the paper. So the big piece that we use is the Census of India. Okay, and so we're going to use the primary census abstract and the migration tables. And so the primary census abstract basically gives you, demographic characteristics about the district, workers in agriculture, workers in non-agriculture, population counts, rural, urban, etc. Okay, and then migration, we're going to focus on intra-district migration numbers. Okay, and so this data is collected every decade, and so we're going to use 6 decades of this data spanning 1961 through to the most recent census, which is the 2011 census. Okay, and as for someone who might work on India, you know that these district boundaries have been evolving over the years. Okay, so there are a lot of splits of districts as well as boundary adjustments over time. And so what we do is we very carefully think about these district boundaries, and so we construct consistent boundaries that span the same area from 1961 to 2011. And so this gives us a sample of 288 districts. Okay, so this is much smaller than the number of districts that exist in India today, but this is precisely because we're aggregating them back to the 1961 level. And then we construct 4 key district level outcomes, and I'm going to come back to these quite often. Okay, so the first we're going to look at is the share of the labor force who are agricultural laborers. Okay, so these are wage workers in agriculture. Then we're going to look at the share of the labor force who are non-agricultural workers. Okay, so everyone in the census who describes working either in household industry or other types of work. The share of the population that resides in urban areas. And finally, the share of male population who are rural to urban intra-district migrants. Okay, so we're going to look at the sectoral reallocation as well as the moving from rural to urban areas. Okay, so we combine the census data with additional data sets. So the first is we're going to use the National Sample Survey. So this is a representative survey that's conducted by the NSSO. And so we're going to use the employment and unemployment modules and the consumer expenditure modules. And you'll notice that the time span for these data sets are much, it's much less than the census, which starts in 61. Okay, so this is sort of the best we can do in terms of survey data that's out there. But the nice thing about this data is that it's super rich in outcomes such as consumption, what sectors people are working in, etc. And so this is going to really allow us to explore the mechanism component of this project. Okay, so we're going to use this sort of to complement our census data, which forms our main source of data for the project. And so this data comes, given that it's survey data, we have either individual level or household level data. And so we're going to aggregate this up again to district level, right? The local labor market level averages of labor shares as well as consumption levels. So that's those are the 2 sources of data that we use, and then we're going to combine this with weather data. So we're going to use, a very, very commonly used data set. So this is the Wilmot and Matsuura 2015. So this is gridded monthly data, and this spans 1951 to 2011. Okay, so for this, we can go back, right? And so we're going to use our whole time period that covers the census. And so here we have monthly gridded data. And so what we do is then reconstruct district level temperature and precipitation measures. Okay, so we're going to do sort of the industry standard computing inverse distance weighted averages of all the grid points within 100 kilometers of the centroid of a district. We're also going to focus on the growing season months. Okay, this because precisely we're thinking about an agricultural channel underlying these effects. And then we're going to aggregate this up to 10-year averages. Okay, so this is where our sort of long-term climate variations come in. So we're going to be thinking about decadal to decadal fluctuations in weather. And so we're going to use these 10-year averages in weather. Okay, so to give you a sense of what this looks like, so here I have some summary statistics of our key, the temperature and rainfall, as well as the 4 different outcomes that I mentioned, split by the years of the census. Okay, and so what do we observe? Okay, the first thing that I want to highlight, if we just look at the first row here, is that we see temperatures rising over time. Okay, so this is not surprising. Okay, and we see that of course this increase also is getting larger in more recent decades. Okay, so from 2011, from 2001 to 2011, temperature average 10-year average growing season temperature went up by 0.2 degrees Celsius. Okay, so that's temperature. When it comes to rainfall, there's a lot more variability, right? So there's no clear trend in terms of an increase or a decline in rainfall over time. So we don't see sort of a monotonic pattern with rainfall. And then we look at agricultural labor share, non-agricultural worker share, urbanization, and across these different shares, we see that it's increasing over time. Okay, and finally we have migration. We see that these numbers are pretty low. So this is intra-district migration for male workers, and we see that that hovers around, about 3%. Okay, so what does this data look like if we were to plot it on a map? So what I have here is simply taking the difference in these different outcomes between 2011 and 1961, right? So just taking the difference between those two. And what I want to show you here is basically that there is a lot of spatial variation. Okay, so firstly, there's quite a bit of variation in how much temperature varies across districts. Okay, so you have districts where the difference in average growing season temperature goes up to more than 1.3 degrees. There are some districts where this difference is really small. Okay, so this is just a split at the district level. And similarly for rainfall, we see that there's quite a bit of variation, right? If we wanted to really look at patterns within each of these graphs, you could see that in the picture on the left with temperature, it seems to be that the internal parts of the country seem to be experiencing higher increases, greater increases in temperature relative.
Yogita, one second. I think Shafat has a clarifying question.
Sure.
Shafat,
sure,
can you go ahead and ask it?
Yeah, so two related questions. One is, so the definition of district has been changing because, as you said, because of administrative changes, but then also there have been, and some of your other work also explores the effect of that. There have been these mega infrastructure schemes in India. So that may also change the effective definition of district if people can travel to nearby districts. So would you be controlling for that in your analysis? And
Right.
secondly, sorry, go on, please.
Yeah, so I think the point that you're trying to make, if I understand it correctly, is that well, over time, infrastructure is improving, and so maybe movement across districts becomes more important because now it's easier to access, right? And so I think we that's true. Infrastructure has improved, and it does allow for more cross-district migration. But what we see in this context is that even in recent years, cross-district migration appears to be quite low. And so we're going to sort of abstract from that, but it could be that there is some amount of cross-district migration going on that we're not going to really capture here.
I see.
Yeah.
And the second one is about, sorry, go on.
No, go ahead.
Second one is about, so I understand that the increase in temperatures have been non-linear over time. So as you mentioned, it's increasing, but is the effect, and I don't know this is just a clarifying question, is the effect of increasing temperatures also non-linear? So so if you go from 24 to 25, that must have different effect than going from 20 to 21. So
Absolutely.
if that's the case, would it not affect the long run estimates? Because what happened in 60s won't have as big of a long run effect due to these non-linearities.
Yeah, no, so I have a slide that's going to talk about this. So it is well established in the literature that there are nonlinearities in terms of extreme heat, right? And so there's adaptation with that. So I will, when I get to the results, I will talk about this. And we do find some evidence that there is some of these nonlinearities do matter.
Okay. Okay.
But great point. Thank you. Okay, great. So I'll just keep going unless anybody else wants to interrupt. But so going back to where I was talking about these maps, right? And so basically what we see is that there is variation in changes in temperature, changes in precipitation, right? They don't perfectly correspond to each other. So we see that internally we see higher increases in temperature, whereas with rainfall, again, maybe unsurprisingly, we see changes in rainfall along the more coastal regions. And when we look at changes in agricultural labor share or non-agricultural worker share, again, there's variation across space, nothing that sort of screams to us like a very clear pattern. Okay, but when we start to just put together these different variables, so what I have here is just a raw correlation of growing season temperature on the horizontal axis and non-ag worker share on the vertical axis. So these are the same variables that we just saw in the maps. We already begin to see this negative correlation, right? So this is not controlling for any regional differences, not controlling for anything else, but we already see in the raw data that there is this negative correlation between rising temperatures and the share of workers in non-agriculture. Okay, and so we're going to take this and we're going to formalize it and bring in an empirical method that's going to allow us to really quantify the effects of temperature on worker shares. Okay, so that's what I'm going to tell you about next is what empirical method we use to estimate these effects. Okay, so we're going to use two specifications. The first is a panel fixed effects model. And what this does is it's going to exploit decade to decade fluctuations in weather. Okay, and so our estimating equation that I have here, it's pretty straightforward. Okay, so we have our outcome. It's one of the 4 different outcomes that I talked about before, right? So agricultural worker share, non-agricultural worker share, urbanization, and migrant share, intra-district migrant share. And then on our right-hand side, we have our decadal average temperature in the growing season. So this is measured over the past decade. Similarly for precipitation, right? So average precipitation in growing season months over the past decade. And then we include district fixed effects, year fixed effects, or decade fixed effects, as well as region, state, time controlled. Okay, so we play around with this, and we have a bunch of different specifications with different fixed effects. And so the idea is that conditional on these district and year fixed effects and the region or state year controls, any remaining variation in decadal temperature and precipitation we can think about as essentially random. Okay, and a minor point for those of you who work in this space, we're going to present our standard errors both clustered at the district level and also have Conley standard errors to allow for spatial correlation up to 500 kilometers. Okay, and so this is our panel fixed effect specification. It's pretty standard. We have our district, year, and then our region, state, times time controls. So that's our first specification. We're also going to exploit longer term variation, okay, which is looking at variation in long-term temperature trends. The way we do this is we estimate a long differences regression. Okay, and so this has been done. Burke and Emmerich have a seminal paper using the long differences. And so what is the long differences? It's basically saying we're going to take the difference in our outcome between 2 periods. And in this case, we're going to take our sample and split it into 2. So we're going to take the difference in outcomes between 1991 and 2011 relative to 1961 to 1981. Okay, so this is looking at a much longer time period. And we do the same transformation for our temperature and precipitation that's defined in the same way as I did in the previous slide. Okay, and so here, the identifying assumption is that conditional on these region fixed effects, right, the long-term changes in district temperature and precipitation are going to be exogenous to the outcomes of interest. Okay, so we have our panel fixed effects model where we estimate this beta. I'm only going to talk about the coefficients of temperature, but we're also including precipitation, and I'll address that when I show you the results. So we're going to have this beta from specification 1, and then we'll have our beta long difference in specification 2. And what's nice is that we can compare these two coefficients. And what this allows us to do is to get some insight on whether or not there's adaptation or whether there's intensification. Okay, so again, this is something that has been done in pretty seminal work by Melissa Dell and co-authors, as well as in the Burke and Emmerich paper that was published in 2016. Okay, so we're going to run these two specifications, and then we're going to do a comparison of these different beta coefficients in order to shed light on whether we see adaptation or we see intensification. Okay, so let me get to the results. Okay, and so the first set of results I'm going to show you are the results from the panel specification. Okay, and so we can focus on the second column for each of these outcomes. Okay, so I have my 4 outcomes here. And so looking at, say, column 2 and column 4, what we find is that rising temperatures appear to inhibit structural transformation. Okay, and so if we want to think about how to interpret what this coefficient means, it tells us that a 1 degree Celsius increase in mean decadal temperature, okay, so that's pretty large, right? So a 1 degree Celsius increase in mean decadal temperature leads to a 17% increase in the share of the labor force that's engaged in agriculture. Okay, and correspondingly, we find a 1 degree increase in mean decadal temperature leads to an 8.2% decline in the share of the labor force that's engaged in non-agriculture. When we look at urbanization and rural-urban migration, we find a pretty precise 0. Okay, so we don't see rising temperatures inhibiting urbanization or intra-district migration. And so this is actually consistent with work that's been done in sub-Saharan Africa that looks at a similar setup, looking at long-run changes in temperature on urbanization, and they find no impacts on urbanization as well. Okay, and so this is the first result to take away, is that rising temperatures appear to inhibit structural transformation. Okay, and so we do this using the survey data as well, and we find very similar results. Okay, so if I were to show you quickly, right? So again, using the same set of specifications, looking at column 2 and column 4, we see this increase in the share of agricultural workers and a corresponding decline in the share of non-agricultural workers. Okay, so one question that comes up quite often is that, well, we know that workers in these settings work in different sectors across the year, right? So employment in agriculture is seasonal, so it's quite common for workers to engage in multiple activities across different sectors within the year. So what exactly are you capturing when you say, there's an increase in workers in agriculture and a decrease in non-agriculture? Okay, so given the census, what we're able to do is we're able to look at the agricultural worker share, both for workers who are classified as main workers and workers who are classified as marginal workers. Okay, and so what do main and marginal mean? We can think about main as sort of a proxy for workers who work in agriculture full-time. Okay, so by definition in the census, it's working in agriculture for more than 6 months of the year. And you can think of marginal as more the short-term seasonal workers. And so what we see, so looking at our total effect, when we decompose it by main and marginal effects, we see that the margin of adjustment is coming from both the main workers as well as the marginal workers, right? So it's not, one of the two, but it's really both. So we see an increase in workers who are now engaging in agriculture full-time as a result of higher temperatures, as well as workers who are engaging in agriculture more on a short-term basis. Okay, the National Sample Survey allows us to also look at what happens to the non-agricultural worker share. And so when we look at it by primary and secondary occupation, we find a similar result with the agricultural worker share. So I'm not going to talk about it too much. When we look at the non-agricultural worker share, we see the declines are coming from workers who engage in non-agriculture as a primary occupation. We also see, the coefficient here is substantial, though not statistically different from 0. So it seems to be the case, that both types of workers are responding. Workers for whom non-agriculture is their primary occupation, workers for whom non-agriculture is their secondary occupation. And so we see with rising temperatures, they're switching to agricultural work, either as a primary occupation or as a secondary occupation. Okay, and so going back to the point that Shafat brought up earlier, so how do we think about nonlinear effects of temperature, right? And so there has been work in the literature that has shown that there are nonlinearities, and so damages from rising temperatures intensify over a certain threshold. Okay, and so what we do in our setup is we take our specification as before, and we interact it with baseline heat exposure. So we take all the districts and we look at temperature from the start of from 1901 onwards, right? So we look at a very long period and say, what does their baseline heat exposure look like from 1901 to 1960 or 1951 before we start looking at them? And then we classify them into districts that are less hot or hot. Okay, so this is just a median split in our sample. So districts that were showing high baseline heat, districts that were showing lower baseline heat. And how do these effects compare across these two different groups of districts? So what we find is that the patterns are actually, so we see that the effect on ag labor share is there across both, right? In terms of magnitude, it's larger in the districts that are hotter at baseline. In terms of non-ag worker share, again, we find that the effects are statistically significant in the hotter districts relative to the less hot districts. Okay, so in terms of patterns, what we find is it's consistent with this idea that there are nonlinearities and that the damages intensify above a certain threshold. Okay, but we also want to acknowledge that these coefficients are not that different from each other. Okay, and so what we're saying is just it appears to be consistent with these patterns, but our evidence is not sort of nailing it in the head there. But it does show that there are some of these nonlinearities going on. Okay, and so now moving on to the long difference specification. Okay, so we just looked at the panel fixed effects model. Now we're looking at the long difference. And so what we find here, if you look at these coefficients, is that these effects are much larger in absolute value. Okay, so the estimates comparing this coefficient to what we had with the panel, right? And so what this tells us is that the adverse effects of rising temperatures appear to intensify in the long run. Okay, and so this means that sustained warming seems to be making reallocation infeasible for an even larger share of households. So those are our main results. Okay, now I'm going to switch gears and talk about some of the underlying mechanisms that could potentially explain the patterns that we find. Okay, so just to quickly summarize what we find, we see that with rising temperatures, we see an increase in the share of workers engaged in agriculture, corresponding decline in workers engaged in non-agriculture. Okay, and so what are the potential mechanisms that one could think about? And I would be happy to hear if you have other suggestions or thoughts of what the mechanism might be. So we're going to think hard about three main mechanisms and a few smaller ones that I'll mention at the end. Okay, so the first is relative labor productivity loss. Okay, so what does this mean? So if rising temperatures cause a greater relative productivity loss in the ag sector relative to the non-ag sector, you would imagine that labor is going to flow from the less productive out of the less productive sector. So labor would flow out of the agricultural sector. Okay, and so this is not what we see, right? So we see that with rising temperatures, as the agricultural sector becomes less productive, we actually see labor flowing in. So this channel doesn't seem to be to make much sense in what we find in our empirical results. The second channel that we're going to consider is what we call local demand effects. Okay, and so this is the idea that with lower incomes coming in from lower productivity, this is going to lead to a contraction in demand for local goods and services, and this subsequently leads to a decline in non-agricultural labor demand. Okay, so we're going to think about that. And we're also going to think about liquidity and mobility cost. Okay, so we know that the cost to reallocation is non-zero. And it could be the case that with reductions in farm incomes, this inhibits the ability of workers to actually afford these costs. And so you could think about these costs as transport cost, or you could also think about these costs arising from informational frictions, knowing someone in the place that you're trying to move to, or credit and savings constraints, and not being able to afford some of these costs up front. Okay, so we're going to think about these different mechanisms. The first thing we do is very quickly just going back to the underlying basis of all these mechanisms is that temperature affects agricultural productivity, right? And so this is well documented in the literature, but we go ahead and do this anyway in our empirical setting. And so we see this relationship between rising temperatures and lower agricultural productivity. Okay, so keeping that in mind, yeah, go ahead. Oh, it's okay. And so the next thing we do is we're going to look at whether features of development themselves modulate these impacts that we find. Okay, and so what we're going to do is we're going to allow the net effects of temperature to vary based on two features of development, which is road connectivity and access to formal credit. And so if local demand effects were to play a role, we should expect effects to be intensified in districts with stronger price effects. So these would be places where road networks are pretty sparse, and in places where it's hard to smooth consumption, okay, where access to credit is low. Similarly, if liquidity and mobility costs play a role, we would expect to find intensified effects in areas where the cost of switching is higher, or again, places with poor infrastructure or limited access to credit. Okay, so heterogeneity across these two margins should yield similar results if these two mechanisms were at play. And so we're sort of just doing a sanity check. So what I do is I'm going to take our main specification and we're going to interact it with a binary variable. If you're a district that has high baseline road density. Okay, so we have a road density measure dating back to the start of our study period. Okay, and so we're going to say, do these effects vary based on your baseline levels of access to infrastructure? And what we see is that the adverse effects that I talked about previously all appear to be driven by districts that have low road density at baseline. Okay, so if you think about this is the effect for districts with low road density, and adding up these two coefficients, we see that in places with high road density, we don't actually see these adverse effects. Okay, so the adverse effects appear to be concentrated in districts with low infrastructure at baseline. Similarly, when we look at the impacts by heterogeneity to access to credit, again, we see that the adverse effects are concentrated in districts with below median bank credit per capita at baseline. Okay, so both of these sort of proxies for development appear to tell us that these effects that we find are driven by places that are lower in terms of these development indicators. Okay, and so that's consistent with both of the two mechanisms that we have, right? It's consistent with local demand effects. It's consistent with liquidity and mobility costs. So how do we disentangle the two? So we think back to local demand effects. What we're saying is that there's going to be a contraction in demand for local goods and services, and that subsequently leads to a decrease in non-agricultural labor demand. So we actually look at what happens to consumption, right? So we're able to look at food and non-food consumption. So this tells us about demand for non-agricultural goods and services. And then we're going to look at non-agricultural worker shares split into different sectors. So we're going to look at the services sector, which is non-tradable, and then we're going to look at tradable sectors like construction and manufacturing. Okay, so I'll show you those results on the next slide. But let me just tell you what we do when we want to think about liquidity and mobility cost, right? So the idea here is that perhaps there are these costs that are non-zero, and when incomes fall, it's harder for workers to overcome these costs. Well, we would then imagine that these costs would be sort of more binding for certain groups of workers. And so we're going to examine heterogeneity in these effects by caste, okay, social grouping, and by educational attainment. Okay, and so if it were the case that liquidity and mobility costs are dominating, we should expect the effects to be concentrated among workers for whom these constraints are likely to bind, which we proxy for by lower caste and lower educated individuals. Okay, so quickly showing you the results. So looking at consumption and sectoral shares, we find that there's a decline in consumption overall, and this appears to be a decline in both food and non-food consumption. Okay, so there's a decline in non-food consumption, decline in the demand for goods and services, right? And then when we look at what happens to the non-agricultural worker share split across different sectors, we find that the effects are strongest in the services sector. Okay, so this is the non-tradable sector of the economy. And so what these results tell us is that this is really consistent with a local demand effects mechanism that I set up before. And then thinking about the liquidity and mobility cost, when we look at heterogeneity by social grouping, so we look at non-scheduled caste, scheduled tribe, and scheduled caste, scheduled tribe. So these are important social groups in India. So you can think about the scheduled caste, scheduled tribe as a proxy for lower caste individuals. We see that the effects are similar across both groups. Similarly, when we look at lower education and higher education individuals, we again find that the effects are similar across workers with different education levels. And so this tells us that perhaps it's not, this liquidity and mobility costs don't appear to be sort of the leading mechanism underlying these effects. Okay, so we also think about a few other mechanisms that you might have in mind. Okay, so you might worry about rising temperatures having a direct impact on non-agriculture itself. Okay, so what we do there is we look at non-agricultural workers in the urban sector, and we see that they're unaffected by rising temperatures. So that tells us that it's something about rural workers, and it's really coming from an agricultural channel. You could also think about a reduction in agricultural productivity leading to land consolidation, which then mechanically increases the share of workers in agriculture. Okay, so we look at the effects on cultivators, and we find that we actually see an increase in the share of cultivators in response to rising temperatures. So that would go against this idea of land consolidation. And finally, you could think about rising temperatures inducing shifts in what people grow, right? So it could be that, I face higher temperatures. I'm going to switch to more labor intensive crops or more dry season crops, and that's going to increase the demand for workers. Okay, so we don't actually see, when we look at these crops, we don't actually see an increase in the amount of labor intensive crops or dry season crops. In fact, we find a reduction. So it doesn't seem to be the case that there's a shift in cultivation, particularly in this direction. Okay, so I'm gonna skip over the robustness because it's not the most interesting, but we do a bunch of things in the paper, and I'm happy to chat more if you have questions about our specification. So let me just take the last couple of minutes. I don't even know where I stand with time, but I'm just gonna wrap up, and then we can talk about questions. So previous work has demonstrated that individuals reallocate across sectors and space in response to short-term weather shocks. But what we highlight in this paper is that it's really important to think about slow onset changes in climate in order to understand how agents are going to respond to climate change. So what we do is we explore medium to long-term responses to changes in temperature. And we find that higher temperatures inhibit sectoral reallocation, and these effects, unfortunately, appear to be intensifying over a longer time frame. Okay, these effects are also particularly acute for individuals living in underdeveloped areas, even within the same country. And so, thinking about what this means for policy or just how we think about these results moving forward, it highlights the need for interventions that make agricultural incomes less susceptible to these temperature shocks that are sort of inevitable in the coming future. And so I'm going to stop here, and I'm happy to take questions from any of you. Thank you so much for your time.
Thank you so much, Yogita. That was a very nice and very clear presentation. So you know the rules. Please let me know through the chat if you have any questions. You can either write your question directly in the chat or just shoot a quick note letting me know that you have a question, and then I can call you up and you can just ask the question directly. So let me open up the floor here. There were essentially two related questions. One is that, your entire story seemed very convincing to me, with the one exception that you don't find these results for inter-district migration. And I was wondering what your explanations for that would be. Would it just be that people are cash constrained to be able to, because usually think about these extreme weather shocks as like a very important factor?
Sorry, Tobias, I lost you for a second.
Sorry, Tobias.
Okay, are you still there? You just didn't able to.
I think you're running into some connection issues. Maybe you can turn off the video.
Okay, let me turn off the video. Okay, is this better? Can you hear me better now?
Yep, you're back.
Yeah.
Sorry about that. We
Sorry about
lost
that.
you from pretty early
it
on.
may be
I
on
think.
my end.
Yeah.
You lost me pretty early on. What is that? Okay, my question was, what is your explanation that you do not find any results for this inter-district migration? Because I would think about these weather shocks to be a very important push factor in the migration decision. This would be number one. And is it maybe a problem of the way you were able to construct this variable, the proportion of the population in a district that actually migrated to other parts of India? That's the first one. The second one is you look at shares out of the total labor force. Have you looked at what happened to the size of the labor force itself? So when you just look, it's not really clear where workers shift. They can shift from agriculture to non-agriculture or vice versa, but they can also just take the decision not to be in the labor force at all. So these relative changes of like agriculture to non-agriculture labor force may also be a result of the decision to enter or exit the labor force itself.
Yeah. No, those are great questions. Should I go ahead?
And then Shafat also has a question. Do you want to take that question now, or do you want to first respond me and then take Shafat's question?
Maybe I'll respond because I tend to forget very quickly. So thanks for the 2 points. Those are both very valid concerns. So with the first point with migration, so we were also quite puzzled as to why we weren't seeing much action with migration. And so we think it comes down to, as you hinted at, the construction of the variable. So what we have from the census is intra-district permanent migration. And so you could imagine that a lot of these workers are moving in and out, but not necessarily, permanently migrating. And so what we see is the number, just the raw means of this variable is really low. It's like 0.02. And so there isn't a lot of room to move on this measure. But so we think it's a limitation of the outcome measure that we have. It's just we are not able to capture, maybe more transient forms of migration. But that's a great point. In terms of your second question about the size of the labor force, so previously we were looking at these shares out of total population, and we did do this check about whether population itself changes, but I don't remember if we did this with the size of the labor force. So that's something that will be on my to-do list to see if we see the actual size of the labor force changing in response to higher temperatures, right? So that's a great point. We'll definitely be sure to look at that.
Okay, thank you. Because I mean, I understand that when it comes to the census data, you probably only have like a sample,
So it's
like
a
a micro
district
sample
level.
where you are able to.
It's
Okay,
actually at the district
you have
level, so
district
it's
level data of
counts.
the
Yeah,
person in District J who lived before 5 years or 10 years prior in District I, something like that.
right, exactly.
Okay, good. Shafat, you want to go ahead and ask your question?
Yeah, so I just have a question about, so you just mentioned that rising temperatures have an effect on productivity, but you're also controlling for the rainfall. So what do you look at maybe I missed it, but were you also looking at the yields, or is there any direct evidence of the effect on productivity?
Yeah.
Apologies if I missed it.
Yeah, so I went through it very quickly. So we do look at productivity, agricultural yield, and we do find this decline. It's true that there's a precipitation effect as well. So even controlling for precipitation, we see that rising temperatures do lead to a decline in agricultural yields.
Okay, great.
Yeah.
No, thanks.
Yeah.
Have you looked at the effect of temperatures going through rainfall by not controlling for it, or would you not want to do that for some reason?
So you mean what would this look like if I would exclude precipitation from the regression?
Right. So just to quantify how much of it is going through.
Yeah. So actually, you know, I don't remember off the top of my head what it is for agricultural yields, but if we look at our main effects, if I just go back to that slide, so if we look at the main effects here, you see that the effect of precipitation is not really there. And when we take it out, it doesn't really change much. But with the yields, that's a good question, because there we do see precipitation playing a role as well, which, you know, we know is also quite well established that rainfall matters. So that's something that I should take a look at as well. I don't know that off the top of my head.
Sounds good. Also, about my earlier point about the infrastructure and the definition of district, I think that may be that's okay, because if you control for that, it doesn't make sense that workers would come in if suppose there's a different size of the district. It won't make much sense that workers are coming in to increase agricultural labor share. So that's something maybe that's going in your favor if you allow for that, in some sense. So you see that the agricultural labor share is going up, so it doesn't make much sense that these infrastructure would lead to that. If anything, that's putting a downward pressure on this thing.
Right. No, that's a great. So you basically gave me the answer to your question. So that's a great point. Yeah.
Yeah.
That's true.
One other thing is you see intensification of the effect over years, right? When you compare beta and beta LD. But isn't that, again, to the point about nonlinearity, isn't that something you'll expect? Because the change later on is from a higher level. So you would expect the effect of that to be more intense as well.
Well, not necessarily if we think that people are able to adapt over time. Right? So if individuals learn to adapt to these temperature changes over time, we don't necessarily expect that difference to be bigger than what we see here. Am I understanding your question correctly?
No, absolutely. I think reduction in long-term effects would suggest intensification, but then I'm just saying that the baseline effect, suppose there is no intensification or they're not adjusting to it. So even the baseline effect is different. So the treatment is very different later on from a 1-point change than the early on.
I see. Yeah, so maybe what we should do is something similar to what we do here, but with the long difference, is to say,
right, exactly.
But I don't think we could do that, because with the long difference, oh, maybe we can. Yeah, no, I think we can. So the long difference, you know, essentially has a district fixed effects built in, because you're taking differences. But yeah, I think we could do something similar. So I think I understand your point now about these non-linearities, even with the long difference. Yeah, that's a great suggestion that we can do.
Thanks.
Thank you.
Okay, thank you. Any other questions? Anyone else want to ask something? So if you have some question, please let me know through the chat, or you're free to just open your mics right now and ask it. Okay, so if there are no further questions, before thanking Yogita, I please would like to draw your attention to the link I posted in the chat. It's a link to a very, very, very short survey. It will literally take you 10 or 15 seconds to fill it out. Please take the time to do so. It's very important to get this feedback on our seminar series in order to improve it in the future. And otherwise, I would like to thank Yogita for a great seminar. And I very much hope that the next time you're presenting, it will be here in person in Kuala Lumpur.
Definitely. I look forward to that. Thanks everyone for your time. And for those of you tuning in from the US, it's a happy Thanksgiving to all of you.
Yes. Thank you. So have a good day, everyone in Asia, and a very happy Thanksgiving in the United States. I hope you have your turkey bride by now.
Thank you very much.
Goodbye.
Very interesting stuff. Thanks.
Thanks everyone. Bye.
Bye.